Hello Internet, my name is Quinn and this is Blondihacks. This is Lathe Skills, a series of quick videos on getting started in machining. This is episode 16, your first lathe project. That's right, I think we finally covered enough skills that we can actually make something, hopefully fun and useful. If you like this content, go ahead and subscribe over there on Patreon. That support is what keeps this content going. Okay, let's dive in. So of course your first question is, well, what are we going to make? Yeah, choosing a first lathe project I think is kind of an interesting challenge because you need something that you can make with the fairly limited skills that you're going to have when you start out. But to me, I think it's also important to make something that's fun and interesting when you're done. And that last part is kind of the challenge. So if you've read a lot of old manual machining books, you'll find that first lathe projects come in a couple of basic categories. You've got your cylindrical square, which is a kind of a specialty item that a beginning machinist doesn't need and doesn't really know what it's for. So you might make this beautiful part, and then when you're done, you put it in a drawer until 2 years later when you actually need a cylindrical square. The next category is projects that require specialty castings. For example, here's a good book on learning machining that I'll link to down in the show notes. But the intro project here is a screw jack that requires a casting kit, which is fine, except that this book was written in 1933, and the company that makes this casting kit went out of business in World War II. So that's not going to help you a whole lot. And while you can make a machinist jack without castings, that's another example of something that actually isn't very useful for a beginning machinist, because when you first start out, you probably only have a lathe, and screw jacks aren't that useful on lathes. They're extremely useful in milling machine setups, but most beginners start with the lathe, and maybe you buy a mill later. So for quite a long time, again, you're going to have made this thing that isn't of any use to you. And then the final category of beginner projects that you see in these books is something like a bushing. And don't get me wrong, bushings are great. They make the world go round. But unless you actually have a specific need for specific bushing, then again, you've made this metal donut. And when you're done, it's like, well, okay, I made a thing. All right, why do I like machining again? So here's what we're going to do. We are going to make decorative rings. Now I hear some of you in the back saying, those look an awful lot like bushings with a chain through them. And to those people I say, quiet down, they're decorative rings. So these are actual pieces of jewelry that I've made and that I wear, and I get a lot of compliments on them. And people often ask me about them. They're great conversation starters. Oh, where did you get that? It's like, oh, well, I made it with my bare hands. And then they say, wait, how did you make that with your bare hands? And then you say, well, actually, with my bare hands and thousands of dollars worth of machine tools. And then the conversation goes from there, or they walk away because you're weird. But either way, these things are fun to make, and when you're done, it's something you can wear and enjoy. And you can achieve all kinds of different looks. So this piece was made with brass, and this guy is about a year old, and you can see it acquires kind of a nice patina. When it's freshly made, it's going to be much shinier and more yellow like this guy. And if you want to keep this look, then you can just clear coat it. Or personally, I prefer to let things acquire their own patina, and so if you leave it unfinished, it will do that. And then here's another option made from steel. And this is actually made from 12L14 steel, not regular mild steel. And if you're going to make this out of steel, I do recommend using 12L14 because you're going to have a much easier time, seeing as how this is your first lathe project. But if you do that and you're making it as a gift, don't give it to children. There is a little bit of lead in this type of steel. It's not going to hurt you as an adult, but kids tend to put things in their mouths. And then depending on the look you want, you can put a decorative chain on it, or for the steel one, I like it with this safety chain on it, so more of an industrial look. You could go with a leather cord. So lots of different options. I would avoid copper or stainless steel. Those are both tempting options for a jewelry project like this. But those are both very challenging to work with for beginners, so I would avoid those. And also don't try to machine precious metals like silver or gold. Or if you do, just send me your chip tray for safekeeping. It's not a bushing. So I've put these rings on chains because I prefer necklaces. I'm not much of a ring wearer, but if you want to make a ring, step one is to measure the biggest knuckle on the finger that you want to wear it on. This is a 600 thou knuckle. It's a standard imperial knuckle. Then make sure that you have a drill bit that will accommodate that. So 600 thou, give it 25 thou for a free running fit on that imperial knuckle, and that leaves us at 5/8. So make sure you've got a 5/8 drill bit. Sorry, they're called drills, not drill bits. I know I just angered all the machinists. Okay, so our next order of business is going to be stock, and I pulled this chunk off the scrap pile. This is some 360 free machining brass, but you can watch my video on how to buy metal if this is your first time doing this and you don't have any scraps lying around. And now the next thing to figure out is what size you need. Obviously the length is not very important. So what it boils down to is you need to do the math on the hole that you want in the center, plus 2 times the thickness that you want on the wall of your ring, and then make sure you've got enough beyond that to machine down and get everything concentric. So for some reference, this ring that I showed earlier, this is kind of a good thickness for a ring that you might wear on a finger, and this is 50 thou wall thickness. And then this guy, which is really more of like a decorative chain type of ring, this guy is 200 thou. So for my little pinky ring that I'll be making, I need a 625 hole in the middle plus 50 thou wall thickness times 2. That puts us at 725 outer diameter. And so I'll use this 1-inch stock, which gives us 275 to remove. Could buy a slightly smaller stock. Make sure you've got probably no less than 50 thou to remove to make sure that if there's a bend or a low spot in the material that you can get rid of that. Now we're going to do this project entirely in a single setup on the 3-jaw chuck, which is part of what makes it a great beginner project. Now when you chuck this guy up, make sure that you leave enough room for your parting tool to get in there and still leave the thickness that you want on your ring. Tighten that guy down. And we're good to go. Now, one of the interesting intellectual challenges with machining is figuring out your order of operations. And I think that's something that a lot of beginners don't realize, is that you, once you get into more sophisticated parts, you will spend quite a bit of time thinking about that. And I've chosen this order of operations not because it's the fastest or the most efficient or whatever, but because I think it's the easiest for a beginner and has the fewest places where you can make mistakes. So the first step, though, is easy, which is facing. It's very often the first thing you do on the lathe, and so I'm set up for that. I have my tool post at a comfortable angle, and I'm going to be doing almost this entire job with this single tool here, and this guy is ground with a flat top, which is typical for brass. That's what you want, and I've got a very generous nose radius on it because brass is easy to turn, so I don't need to worry too much about tool pressure, and this is going to give me a really nice surface finish in a single pass, easy peasy. Okay, I got my lathe at 450 RPM, which feels about right for this operation, and we're just going to touch off on my face here, and once I see a chip form, then I'm just going to wind my cross slide out, and then down here on my carriage hand wheel I'm going to dial in about 20 thousandths. It's always a good first facing pass, and then I'm going to lock my carriage, and then I'm going to wind in my cross slide, nice and easy. Nothing to it. Making chips. If you've been following along in my lathe series, this might be your very first chips. And if so, welcome to machining. You're going to love it. So this is all in real time here, so you get a sense of the pace that I'm using. And I'm not in a hurry. You can go faster than this, but you don't have to. There, and if your tool height was good, then you won't have any kind of nubbin or anything left on there. Now we need to set up to turn this outer diameter, and to do that we need to square up our tool post. So here's a quick and dirty way to do that. Since we've just faced the end of this work, we know that the end of this work is square to our ways and parallel to our chuck, so we can just use that to square up our tool post. So we'll just loosen this guy off and wind our carriage in, and then just bring this guy in. And with it loose, it'll square itself up nice and easy. And then just kind of snug it up a little bit, and then you can move it away and put a little hurt on it. Okay, so now we can come in here and do this turning. Now we're going to be working a bit close to the chuck, which can be scary for a beginner, but you need to get comfortable with this because in here close is where all your rigidity is. So might as well start getting comfortable with that now. So a simple trick here for this turning operation, because we're going to be starting out here and coming in, we want to make sure that we don't come in too far and crush the chuck. So an easy way to do that is just kind of line it up out here with the machine off. If you're not sure, you can always just stick your machinist scale there on the edge of your tool, and you can see that we're going to have clearance there. Now with this guy set up where you want it, then just start the lathe. And then just wind the cross slide straight in a little bit and just make a little mark. So now we know how far in we can safely go. When the chuck is spinning, it can be a little hard to see exactly where the front face of these jaws are, so that little mark makes it a lot easier. Okay, now for turning, I'm using a little bit of a lower spindle speed because we're on the outer surface of the part now. So I'm at about 380 RPM, which feels about right for this brass. With any turning operation, the first step is always to find that surface. So I'm just going to wind in here until I see it touch that surface. There we go. And then I can just wind this guy clear of the work. And then down here on my cross slide, I'll go ahead and put it on the closest whole number there. And now I can dial in, let's say 10, 20 thousandths will be a good first pass here. And this is a direct read hand wheel, so it's reading the amount of diameter reduction that I will get by doing this. So we're going to remove 20 thou just to sort of clean up the surface. And away we go. And we're just feeding by hand here. Don't have to use the power feed on your first time out. Just focus on turning that carriage hand wheel smoothly and consistently. The smoother you are with it, the better finish you'll get. And we've got that witness mark, so we don't have to worry about the chuck jaws. We're just going to come in, and so we encounter that line. And we're good, and we'll wind it back out. Now normally you'd be ready for your next step, but this piece of scrap I have here has a little bit of a step on it because it was previously used for something else. So I'm just going to turn that down and I'll bring you right back. Okay, now that we're all cleaned up, nice and shiny, we have a machined surface now that we know is concentric to the spindle axis, so we can take our first measurement. Now we're not making racing engine parts here, we're making jewelry, so we don't need a ton of precision, and the good old caliper here is going to do everything that we need. So we can take our first measurement now, and we can see that we are at 944. So we're going for 725, so we've got 219 thou to take off of there. So now we want to plan our passes. Now we've got 219 to go, so I'm going to do 2 passes of 100 thou, and then that should leave us with 1 pass of 19. Which is kind of, you want to kind of break it up so that you've got some big roughing passes and then something in the sub 20 thou range as your finishing pass, and that will absorb any errors that you make as you get closer and closer to your final dimension. And of course, you know, this is jewelry, final dimension. What does it really matter? Well, precision takes practice, so you might as well take every chance you get to practice hitting dimensions, because someday when it does matter, when you go to build that racing engine, you want to have that practice under your belt. So same spindle speed here, I'm at 380, 390, and I'm gonna dial in 100 thou, and away we go. And we could use cutting fluid here, but for this little brass project, it's not strictly necessary. As you can see, 100 thou pass on brass, really not that difficult, even with my little benchtop machine. So our first 100 thou, so our second 100 thou pass. The roughing pass is done. We can now see how deep our finishing pass needs to be. Take a little measurement here. So we are at 743, which means we have 18 thou left to go. We expected 19 thou, so that is why we do this. I made some little mistake somewhere that cost us 1,000th, and if I'd just blindly gone in and done a 19 thou pass, we would have ended up 1 thou under dimension. All right, for this finishing pass, I got the spindle speed higher now. I'm a little over 500 RPM. Both because our diameter is now a little smaller and because I want to get the best possible surface finish, so higher spindle speed, and I'm going to feed nice and slow. Once again, the more evenly and consistently you feed, the better finish you'll get. And on this last pass, I'm going to wind the cross slide out. I'm not going to drag the tool back across the work and risk scratching it up. Okay, now I'm set up with a parting tool, and this is going to seem a little unconventional, but this is back to what I said about choosing your order of operations. This is going to make sense later on. So what we're doing now is setting the final thickness of our ring. So again, this isn't super precise, so I can just set it with a machinist scale here, and I'll go for 100 thou, which should be a nice delicate ring for my pinky. And then I'm going to go ahead and lock that carriage. And you'll notice that I'm using a traditional ground parting tool, not a parting blade. And this wide parting tool is going to help us later on. This particular tool is the one that comes with the pre-ground set from Grizzly. And there's a link down in the show notes for this guy right here. Now I've got my spindle speed way down now, about 140 RPM. And I've got my carriage good and locked. What I'm going to do is just come in here and find the surface. Just touch off, okay. Now I'm going to look at my hand wheel, and the depth that we want here is a little more than the wall thickness of our final ring. We only need to go in that far. We're not really parting anything off here, we're just making a groove. Now at this point it's critical to know if you have an indirect or direct read hand wheel, because you might be reading the depth of cut or the diameter reduction. In my case I'm reading the diameter reduction, and we need a 50 thou wall thickness on our ring, so we need a total diameter reduction of 100 thou. And so that's how far I'm going to wind in. A little cut on all there. Never a bad idea. Okay, in we go. So I'm just winding in nice and easy. Okay, there's my 100 thou. I'll come back out. All right, the next step we're going to do is actually to deburr this part with a fine cut mill file. And this is kind of our best opportunity to do this. This is another great example of how your order of operations really takes some thinking, and the more well-planned your order is, the easier your part is going to be to make. So obviously we can deburr the outside edge, but the reason that we did that parting now is that now that that groove is cut, it gives us an easy chance to come in here and deburr the back side of that part. And of course you can always deburr after the part's, finished, but with a round part you get a much nicer result if you can deburr it while it's spinning in the lathe. Okay, so I've got my spindle speed up a little bit now, about 200 RPM, and all these RPM numbers I'm giving you, plus or minus 100 is fine. It's really not that critical for what we're doing. Okay, so just like I showed in the deburring video, we're going to go ahead and just give these guys a nice light chamfer. Okay, there's the outside. Now the inside's a little trickier, but just get it. There's the result of our chamfering right there. Yeah, you can see how nice that's going to be. Now at this point you might be saying to yourself, wait a minute, that looks an awful lot like a disc, and the defining property of a ring is that it, has a hole in the middle, and that's what we're going to do right now. This is our tailstock's time to shine. This guy's been hibernating until now, but now it's time for the good old Jacob's chuck. Let's get set up for drilling that hole. So we'll start with the number 2 center drill here, and we want lots of spindle speed because we're drilling a very tiny hole right in the middle where there's very little surface speed. So got the lathe cranked up to let's say 800 RPM, maybe 900, and we'll get a little cutting oil on there and get it done. Before we drill the big hole, let's take a moment to talk about rake angles on cutting tools, because this is going to be important. For brass, on these lathe tools, you want the top surface to be flat. You want 0 back rake on that cutting edge. For steel, you want somewhere between 8 and 15 degrees of angle on the top of that cutting tool. And those angles are tailored to the material, how it shears, and these angles are important. Now what a lot of beginners may not realize is that those angles also apply to drills. These drills have cutting edges on the ends, just like our lathe tools, and they also have those rake angles on them, and those rake angles also need to match your material. So any old factory drill that you buy is likely going to be ground for steel, and you can buy special brass drills, but they're very expensive, and the average hobbyist isn't likely to have them. So we can use these steel drills on our brass, but we need to use a couple of tricks, which I'm going to show you. Now the effect here gets much worse the larger the drill is. So on small drills you won't notice this. You just drill a hole and the material doesn't matter a whole lot. But on these larger drills that are taking bigger bites of the material, that rake angle starts to matter a lot more. So for that reason and for others, we're going to be doing this in a lot of stages because we're going all the way up to 5/8, which is a pretty big bite for brass when you're using the wrong drill. So we're going to start with a 1/4 inch, which is always a good pilot size to start with. Now we need to think about our depth. The goal here is to get the full diameter hole a little bit deeper than the thickness of our ring. And the thing we need to be thinking about is the distance of the pilot point on our largest drill that we're going to be using, which is this 5/8. So you can measure this distance from here to here, and just a rough measurement with a caliper is fine, and you'll find it's about 300 thou. So we want to make sure we're going at least 300 thou so that when we get to this guy, the widest part of the drill has gone a little deeper than the thickness of our ring. And to do that, we're going to use these marks on the tailstock quill. So we're just going to touch the end of the drill bit in, see which line we're at, and then we're just going to count 300 thou from here. All right, away we go. Got my spindle about 400 RPM, a little cutting oil on there. Tailstock is locked. And away we go. All right, our next drill is going to be this 5/16, and this is when you're going to start noticing the difference with using the wrong drills. So the effect is that because this cutting edge here is sort of too much of a hook, if you like, because of that back rake, what's going to happen is the brass wants to grab the drill and pull it in faster than it can cut, and you'll see that the effect of that is that the drill, you'll feel the work kind of pulling on the drill. Now the failure mode of this is that it starts biting too deeply all at once and overwhelms the torque holding your drill in place, and it'll spin the drill in the Jacob's chuck, which is not very good for the drill or your Jacob's chuck. So to prevent that, what we want to do is basically take very light passes to keep that cutting edge from digging in too deep. So just feed very, very gently with this, and you'll be fine. So my spindle speed is the same as the 1/4 inch drill, and I'm feeding nice and gently, very slow, so you can hear it wanting to grab. Okay, now it's cutting nice. And again, feeding gently, don't let it grab. And the depth here is not so important because we'll just feel it bottom out. We don't actually have to measure the depth now. And there's the bottom. Here's our final 5/8 size. Lots of cutting fluid on there. And I got the lathe slowed down to about 150 RPM now. Now, watch what happens. You'll know when you're in far enough. And you'll see why we did that parting the way we did. There's our ring. So here's our ring, fresh off the lathe. It's looking very pretty indeed. Now resist the urge to slide this guy on your finger immediately because there's going to be burrs on those inside edges from the drilling, and it's going to be pretty sharp. So let's get that cleaned up. To clean this up, we can use a deburring tool like this guy, and you'll find a link to this guy in the show notes. And it's a little bit fiddly to work with a part this small, but we can just kind of hold it on there like so and give it a few little twists. There's our finished ring, ready to be slid on your finger or slid on a chain or slid on some part of someone that you love. So make a few of these for yourself. It's fun and you will learn a lot. And it's definitely not a bushing. Thanks for watching.